Hi, my name is Kevin Dunn. I'm the Elliott Professor of Chemistry at Hampton-Sydney College, and today I'll be showing you how to measure the alkalinity of soap. Soap alkalinity is one of the most important tests you can make because you don't want to sell soap that's overly alkaline and harsh to your customers. In order to make this test, you need some soap that you're going to test. This soap was made yesterday, so I expect it still has some alkalinity left in it. You need some grain alcohol. Grain alcohol comes in two varieties. There's the kind you can buy at the liquor store. If you want that, you want to buy Everclear or something that says specifically grain alcohol. If you want to go to the hardware store, you can buy denatured alcohol, which is the same thing with a little bit of poison in it to discourage you from drinking it. The next thing you're going to need is an appropriate scale. We need a scale that can measure to 1/100th of a gram. This is the iBalance 201, an excellent scale. You can buy it for less than $100. Nice thing about it is that it plugs into the wall rather than running on batteries. But if you want to, you can get by on a little pocket scale like this. This costs less than $50, but it runs on batteries, and because it has an auto off feature, it's going to turn itself off from time to time. You'll have to turn it back on. You also need some other equipment. This is a really handy little thing to have. It's called an Erlenmeyer flask. And while you could get by with a Pyrex measuring cup, it would be worth the investment to buy some of these. This is a 125 milliliter Erlenmeyer flask. Nice thing about Erlenmeyer flasks is they're made for mixing things without having a stir rod. You also need some spatulas. You could use a spoon or a knife. Anything made of stainless steel is going to work for that. You also need some chemicals. We're going to be using citric acid and either sodium hydroxide or potassium hydroxide. We're going to be making these up in 0.5% solutions. That's what these are. And we also need, very importantly, some phenolphthalein. Phenolphthalein comes as a dry white powder, but you can often buy it as a solution in alcohol like this. I've stored this in a eye drop bottle because that's a very convenient dispenser, but if you buy it as a liquid, it will probably come in a convenient dispensing bottle. We're going to make up solutions of citric acid and sodium or potassium hydroxide. You want to make that up as 0.5%. That means you could dissolve 0.5 grams of either material in 95.5 grams of water. Another convenient way to make it up the same way is just to measure out however much of the dry material you want, multiply it by 19, and that's how much water you need to get to the same place. I'm now going to demonstrate how to make up your citric acid solution. For this you need some citric acid, which comes in two varieties. There's anhydrous citric acid and citric acid monohydrate. If you can get it, you'd rather have the anhydrous citric acid. If you can only find the monohydrate, or if you're not sure which one it is, you can dry it in an oven at 200 degrees for about a half an hour, and that will drive off any residual moisture. So what we need to make this solution is 1/2 gram of citric acid. I'm going to do this weighing by difference, which is a really useful and important technique. I'm going to take a cup, put it on the balance, press 0. I know I want about 1/2 gram, but this is going to save me a lot of headaches. Oh no! It's 1.57 grams. No problem. I press the 0 button. I'm looking for 1/2 gram, so I just take some out. What is that? That's 0.05 grams. There's 0.13 grams. There's 0.25 grams. 0.31 grams, 0.34 grams, 0.46 grams. I want to hit 0.5 exactly. And now I'm at 0.53 grams, but no problem. It hasn't gone anywhere. I just tapped the spatula a little bit. 0.52, 0.51. And I've hit 0.50 exactly. I've now weighed exactly 0.5 grams into my container. I'm going to play the same game with water that I played with citric acid. I want to get exactly 99.5 grams. So I place the cup on the balance, press the 0 or tare button. I know I want 99.5 grams. It's hard to hit that exactly. 74. Oh no, 103 grams. That's too much, but no problem. I press the 0 button. I know that's over 100 grams. I'm going to pour most of it into my bottle, but not all of it. Because I've tared it, this is telling me I've transferred 83.79 grams. There's 86. There's 89. 92. 95. 98. 98.9. There's 99.55 grams. That's too much. So all I do is put a drop back. 99.52, 51. And that's probably close enough. I'll try one more drop and see if I can hit it. 99.49. 99.49, 99.51 is fine. The dropper is now empty. All the water that isn't in the cup is now in my container, and it's 99.48 grams now. I put the top on, shake it up, and now I've got a solution of citric acid, which is exactly 0.5%. So we're going to begin by making up some neutral alcohol. I need 50 milliliters of alcohol in an Erlenmeyer flask. And it doesn't have to be exact. Something in the neighborhood of 50 milliliters is fine. So I've got 50 milliliters of alcohol. I'm going to add a few drops of phenolphthalein indicator. It starts out colorless, and because the alcohol itself might have some residual alkalinity in it or acidity, I'm going to neutralize it with my 0.5% potassium hydroxide solution. I've got 2 medicine droppers here. I want to make sure that I don't mix them up so that I can have one for one bottle and one for the other. So I'm just going to add a drop or 2 of this and see what it does. Nothing yet. So what's nice about an Erlenmeyer flask is you can just swirl it to mix it. And what I've got now is alcohol that is very faintly pink. If I put it on a white piece of paper, I can just barely make out the pink color of the solution. And now this alcohol is now neutral to phenolphthalein. So now that I've done that, I need some soap. I'm going to take a cup, put it on my balance. I'm looking for something in the neighborhood of 1 gram of soap. So I'm just going to take a spatula and get some soap shavings. I've now got a little bit more than 1 gram of soap, which is what I need. I'm going to put my Erlenmeyer flask on the scale, press 0, and now I'm going to transfer some soap into the Erlenmeyer flask. There's 0.31 grams. There's 0.60 grams. .77. I happen to hit exactly 1 gram, which hardly ever happens. 0.99 grams. It doesn't matter that you hit the mark exactly, but I do want to record the exact weight, whatever it is. This is 0.99 grams of soap. Simply swirling it will mix it up. And you can see the solution has become more pink, telling me that this soap is alkaline. If the pink color went away, then you know that your soap is not got residual alkali in it and it is as neutral as it's going to get. So I'm going to have to heat this, but I want to heat it carefully. I'm going to use a microwave oven. Ethanol is flammable. Grain alcohol or Everclear or denatured alcohol is flammable, and I don't want to boil my alcohol away. So I'm going to be very careful with this. I'm only going to set it for about 10 seconds at a time. I'm going to start out with 5 just to make sure. And that wasn't too much. So I'll get crazy now and set it to 10. I'm going to feel it in between to see how hot it is. It should be hot, but I don't really want it to boil. So it's already hot. I'm going to move down to 5 seconds now. And what I see now is that all of my soap has dissolved in the alcohol. If there's a little bit that doesn't dissolve, don't worry about that. That will dissolve as the experiment continues. But what I've got now is 0.99 grams of soap dissolved in 50 milliliters of ethanol with some phenolphthalein indicator, and it's quite pink. Next thing that I'm going to do is to break out my 0.5% citric acid solution. I'm going to place it on the balance, press the 0 button, and now I'm going to be weighing from the balance into the beaker. I'm just going to take a little bit. Now you see what's so nice about the Erlenmeyer flask. I can just gently swirl it. You can see I'm getting very close. The pink is almost gone. And we are probably done. I'm going to record that as 0.32 grams. But just in case, let's see if one more drop makes it even less colorful. And it did. So 0.32 grams was not quite enough. The pink color is now completely gone, and that's 0.36 grams. Notice that at each step I empty the medicine dropper back into the original container because I want it to be that the only citric acid is either in the container or in my Erlenmeyer flask. So, the calculation we need to make is quite simple. We're going to take 3.123 times the weight of the citric acid. In this case, it's 0.38 grams. And we're going to divide by the weight of the soap, which was 0.99 grams. That's 3.123 times 0.38 divided by 0.99. That's 1.2. That's 1.2 parts per thousand, or if you want to get that in percentage, it's 0.1% of residual alkalinity. The industry standard for soap alkalinity is less than 1 part per thousand alkalinity, and ours is at 0.12, which means it's really close to being industry standard. But anything less than that is going to be fantastic. And in fact, if your phenolphthalein doesn't turn pink at all, that means you're already below that 1 part per thousand industry standard. You may be wondering why we have to use denatured alcohol or Everclear in order to do this test. You might be tempted to use distilled water instead. So I'm going to show you what happens if we use distilled water instead of denatured alcohol. I'll start with 50 milliliters of distilled water. I'll add my phenolphthalein indicator as before. I will add some KOH to get it faintly pink. And you can see it's quite brightly pink. Even a little bit of alkalinity is going to make it very brightly pink. I'll now add some soap. 0. Sorry, let's do it this way. 0. There's 0.5. 0.7. 0.94. 0.97. 0.98. I'm going to try to get as close to our previous number as possible. and there's 0.99. So that's the same amount of soap as in our previous test. Put it in the microwave as before. Okay, we've now got our soap dissolved in water instead of alcohol. And we know from the previous test that it should take 0.38 grams of citric acid to get to the end point. Press the 0 button or the tare button as before. I'm already to 0.39 grams, which is past our previous test. And we can see this solution is getting less pink, but it's just gradually fading from the pink color. Whereas in alcohol, I got a sudden change from pink to colorless. We're now over 7 grams. And while the pink color is less, there's no clear end point. There's no point where I can clearly say, ah, that was the last drop. I'm now over 8 grams. And here I have to ask myself, is it pink or is it not pink? I think it's still a little pink. Still pink? Yeah, I think it is. I'm now over 10 grams. Is it pink or is it not pink? I'm having to guess. I don't know. How pink is it? I think I'm finished, but I'm not sure because I can't quite tell. Is there still a little pink there? We're now at 11.33 grams. The correct answer was 0.36 grams, 38 grams. So I'm way, way more than 10 times. I'm more like 30 times the amount that I needed. That means if you were doing this test in water, you would fool yourself into thinking that your soap was a lot more alkaline than it actually is. The reason this doesn't work is that soap forms a buffer system in water. That means a buffer is a solution which resists changes in pH. So as I add acid to a buffered solution, instead of changing suddenly, the pH drops gradually. And instead of getting a sudden color change from pink to clear, I get a gradual color change from pink to clear. So you don't want to use water for this test. You want to use denatured alcohol or grain alcohol or Everclear instead. There are 2 more tests that you can make that are a lot simpler than this. If you don't want to go to the trouble to get a number for how alkaline your soap is, you might simply wonder, is it alkaline or is it not alkaline? Is it too alkaline for me to sell, or is it neutral enough for me to sell? The first test I'm going to show you is the old school way. All you need is a bar of soap and a tongue and a finger. I'm going to get my finger wet, touch it to the soap, preferably an interior section that hasn't been exposed to the air, and I'm going to pretend that it's poison. It's going to kill me, but I'm going to try to take as little small a taste as I can. And I get a little zing out of it. And now I can be a little more aggressive, now that I know that it's not going to kill me. Oh yeah, that's what a zing tastes like. So you can train your tongue to detect excess alkali in soap. The second way, if you don't want to do that, is you can use the same phenolphthalein indicator that we used for the more elaborate test, and you're just going to put a drop on the soap. And I can see it turn pink on the surface. If the soap is not alkaline, then it won't turn pink. But if it is alkaline, it will turn pink. If you'd like to know more about this test, you can find it in Chapter 15 of my book, Scientific Soap Making. I hope you've enjoyed this video as much as I have. Check out my other videos on the Handcrafted Soap and Cosmetic Guild website.